Dear students, today we are going to discuss about the topic method of preparations of amines. Various method of preparation of amines are the method commonly used for the preparing amines are alkylation of ammonia, Gabriel synthesis, reduction of amide, reduction of nitrile, reduction of nitro compound, reductive amination of aldehyde and ketone, reduction of acid. These are the commonly used for the method of preparing amines. The first one, the alkylation of ammonia. Alkylation of ammonia, this ammonia react with a nucleophile with alkyl halide to give a primary amine in a nucleophilic substitution reaction. Ammonia react as a nucleophile with alkyl halide. Rx plus 2NH3 will give RNH2, that is amine, will give a primary amine. This is the primary amine plus NH4 X minus NH4 plus, that is for example RCl, alkyl chloride. Ammonia react with ammonia will give a RNH2 plus ammonium chloride. Yield are often poor as the product. A primary amine RNH2 or itself a nucleophile can react with more alkyl halide. The results are mixtures containing primary amines, secondary amine, tertiary amines and quaternary ammonium salt. The results are the mixture containing primary amines, secondary amine, tertiary amines and quaternary amines. The alkyl halide itself acts as a nucleophile, then it primary amines then react with this nucleophile alkyl halide will give a secondary amines, tertiary amines, quaternary ammonium salt. This can be avoided by large excess of ammonia is used. This can be avoided by large excess of ammonia is used. As aryl halide do not undergo simple nucleophilic substitution, and aryl halide does not undergo simple nucleophilic substitution reaction. They cannot be prepared using by this method. Aryl halides they cannot be prepared by using this method. This is the reaction of alkylation of ammonia. The alkyl halide react with ammonia will give a primary amine plus NH4 NH4 plus X minus. This is the primary amine. Primary amine react with RCH2X. Then another alkyl halide will give a secondary amine. This secondary amines will react with another alkyl halide will give a tertiary amine. This tertiary amine react with another alkyl halide will give a quaternary. Alkyl halide itself act as a nucleophile. Alkyl halide itself act as a nucleophile. This is the alkylation of ammonia. Alkylation of amine by alkyl halide. Alkylation of amine. It's a nucleophilic substitution reaction. Next, reduction of amide. Reduction of amide is the reaction type is the nucleophile acyl substitution then nucleophilic addition. This is the mechanism. Nucleophilic acyl substitution then nucleophilic addition mechanism. This is the ammonia amide RCONR2. They can be reduced to amine. This can be done by the reducing agent like lithium aluminum not less reactive NaBH4. Lithium aluminum hydride ആണ് യൂസ് ചെയ്യുന്നത്, but not the less reactive sodium borohydride. Sodium borohydride less reactive ആണ്, അമൈഡ്സുമായിട്ട് less reactive ആണ് sodium borohydride. Lithium aluminum hydride ആണ് ഇത് commonly യൂസ് ചെയ്യുന്ന reducing agent, reduction of amide into amines. The lithium aluminum, this is the reagent എന്ന് പറയുന്നത് lithium aluminum hydride in either solvent. Lithium aluminum hydride in either solvent. This is the reagent. Next, RR dash RR double dash is the maybe either alkyl or aryl substituents. RR dash or R dash may be either alkyl or aryl substituents. This is the general reaction. Lithium aluminum hydride react with the primary amide will give a primary amines. Secondary amide to react ചെയ്യുമ്പോൾ secondary amine will get a secondary amine. Tertiary amide to react ചെയ്യുന്ന സമയത്ത് tertiary amine will get a. Understand? RCONH2 primary amide will lithium aluminum hydride primary primary amide reduced into primary amine, secondary amide reduced into secondary amine, tertiary amide reduced into tertiary amine. This is the reduction of amide. Next, fourth reaction is the reduction of nitrile. Reduction of nitrile. Nitrile can be converted to primary amine by reaction with lithium aluminum hydride. Nitriles can be converted to primary amine reaction with lithium aluminum hydride. This is the reaction. Nitrile is the RC triple bond, and that is the nitrile RC reduced into, in presence of lithium aluminum hydride. Hydrolysis will get a primary amine. When aromatic nitrile, this is the aryl nitrile, benzene, cyanobenzene, react with the lithium aluminum, will get a RCH2 NH2. This is the general reaction. Going from reactant to product, simplify. Converted to triple bond into single bond, add 2 hydrogen to the carbon and the nitrogen. This is the mechanism. This is the reduction of nitrile. Reduction of nitrile in presence of primary amine reduced. Nitrile can be reduced by, that is reduced to primary amine by reaction with the lithium aluminum hydride and hydrolysis. This is the reaction. RCN is reduced into primary amine. RCN reduced into primary amine. Next, reduction of nitro compound. Reduction of nitro compound. In this case, aliphatic compound that can be reduced by this nitro compound. This is this nitro compound that in presence of iron or ferrous sulfate, in presence of H plus ion, it will convert into amine. It is a primary amine. Secondary amine. The nitro group can be easily reduced to amino group with metals such as zinc, iron, tin in acidic solution. Nitro groups can be easily reduced to amino group with metal such as zinc, tin, iron in acidic solution. Addition methodology involves the catalytic hydrogenation and use the reducing agents such as hydrazine and titanium trichloride. This is the reaction, reduction of nitro compound. Aromatic amines normally prepared by reduction of corresponding aromatic nitro compound. This is the simplest reaction. In presence of tin, HCl, heat OH minus. In presence of OH minus, nitrobenzene react with tin, SN. In presence of acidic solution, HCl, heat. In presence of OH minus ion, we will get anilin. This is the reaction. And this is the aliphatic nitro compounds that they react in presence of metal, their salt, metal sulfate, FeSO4, in presence of zinc, tin, and iron in acidic solution, H plus solution. We will get a amine. This is the reduction of nitro reaction. Next, reductive amination of aldehyde and ketone. This is the reaction, a reductive amination of aldehyde and ketone. Aldehyde or ketone can be reduced by catalytic or chemical reduction in the presence of ammonia. Primary or secondary amine producing primary, secondary, tertiary amines. When aldehyde or ketone reduced by catalytic or chemical reduction in presence of ammonia or primary or secondary amine producing primary, secondary or tertiary amines. This is a Locard reaction. This method reactions Locard reaction. This Locard reaction, this chemical reaction that convert aldehyde or ketone to amine. Aldehyde or ketone to amine by reductive amination in presence of heat. This reaction named after Sir Rudolf Leuckart. This proceeded via two mechanisms, one using ammonium formate and other using formamide as the reducing agent. One using ammonium formate and other using formamide as the reducing agent. This is required at a high temperature usually between 120 to 130 degrees Celsius under the presence of formamide, and the temperature can be greater than 165 degrees Celsius. This is the general reaction. When R on CO R2, there is an aldehyde or ketone RCO. For example, CH3CO CH3 is acetone, CH3CO CH3 CH3C double bond OH, that is aldehyde, acetaldehyde. React with ammonium acetate. Ammonium acetate will get a amine. Will get a amine. This is the amine in presence of acidic condition. This is a reaction. It is the chemical reactions that convert aldehyde. It's a chemical reaction that convert aldehyde or ketone to amine by reductive amination in presence of reaction named as Rudolph-Leucott. This proceeds via two mechanisms, one using ammonium formamide, other using formamide as the reducing agent. This is the important method of preparation of amines. First one, the alkylation of ammonia. Second one, Gabriel synthesis. Third one, reduction of amide. Fourth one, Gabriel synthesis. The Gabriel synthesis is not important for in case second semester. This is the method of mainly method of preparation of this reaction is the reaction type. The Gabriel synthesis is very important. In this reaction type, nucleophilic substitution, then nucleophilic acid substitution. This the reaction is first one, the nucleophilic substitution, then nucleophilic acid substitution. This advantages of this method that alkylation is avoided. The advantages is method that over alkylation is avoided. The reaction of phthalimide with KOH remove the NH proton, giving the imide ion a good nucleophile. The reaction of phthalimide with KOH remove the NH proton, giving an imide ion. It's a good nucleophile. Nucleophile substitution by the imide ion. It is a HN2 2 minus on the alkyl halide generate an intermediate in alkyl phthalimide. Hydrolysis or hydroxynolysis liberate a primary alkyl amine. Aryl amine cannot be prepared by this method. Aryl amine cannot be prepared by this method. This method in preparation of aliphatic amines do not undergo simple nucleophilic substitution. This is a general reaction. Phthalimide in presence of KOH, RX, alkyl halide, NH2, NH2, hydrogen. In presence of hydrogen, will get a primary amine or NH2. This is the reaction. This is a very important reaction, Gabriel synthesis. This is the important method of preparation of amines: alkylation of ammonia, Gabriel synthesis, reduction of amide, reduction of nitrile, reduction of nitro, reduction of acid. The reduction of acid is commonly used for the preparation of aromatic amines, aryl amines. Reduction of acid commonly used for the method of preparation of aryl halide. This is the main important method of preparation, method commonly used for preparing amines. Reduction of amide, reduction of nitrile, reduction of nitro compound, reductive amination of aldehyde and ketone. Okay, thank you all.